Welcome to another session on nucleophilic addition reaction. And as you know that in the previous video lecture, we were talking about addition to alpha beta unsaturated carbonyl compounds. And from the previous sessions, you know that addition to alpha beta unsaturated carbonyl compounds may lead to the formation of a direct addition product or a conjugate addition product, or in other words, it may lead to a 1,2 addition product or a 1,4 addition product. In the very last session, we talked about or we discussed different factors that may affect the progress of a reaction, leading it to a direct addition product or a conjugate addition product. And these were the four factors that we saw in the previous session, and I had told you that we will discuss each of them one by one. So in the today's session, we will talk about the effect of reaction conditions on the formation of a particular product. So let's get on with it. So let's see how reaction conditions may lead to the formation of a direct addition product or a conjugate addition product. You already know that when we try to analyze the effect of a variable on a particular process, we need to keep everything else constant. So you know that the fate of the reaction is decided by four different factors. That is the reaction conditions, the structure of the substrate, or the nature of the nucleophile, or the organometallic compound that you have used. So in this case, as we are talking about reaction conditions, so we will change the reaction conditions, keeping everything else constant. That is, the starting material or the structure of the starting material will be similar in every case, and also the nucleophile will be kept similar. So from addition to alkenes or addition to carbon-carbon double bonds, you know that the direct addition product is favored by low temperature or short reaction times. Direct addition product is also known as 1,2 addition product. We discussed the same reaction in case of addition to addition to dienes, conjugated dienes, and we saw there that at low temperature 1,2 addition product or direct addition product is favored. The direct addition product is also known as the kinetic product, and it is formed at a faster rate, or you can say that it is formed quickly in short reaction times. On the other hand, the conjugate addition product or the conjugate addition reaction is favored by high temperature. Conjugate addition product is also known as the 1,4 addition product, or it is the thermodynamic product. Because it's a slow process, it takes longer time than the kinetic product to be formed. So let's see this with the help of an example. We have the simplest of the alpha beta unsaturated carbonyl compound. It's a ketone which is conjugated or which has a double bond at alpha and beta position. When you react it with sodium cyanide in the presence of HCN at 5 to 10 degrees centigrade. Now this means that it's a low temperature. So we are carrying out this reaction at low temperature. Reaction conditions primarily mean the temperature at which you are performing the reaction or the pressure. So here we are concerned with the temperature. So if you keep the temperature low at 5 to 10 degrees centigrade using sodium cyanide as the nucleophile, what you see here is that we get a cyanohydrin as a product. This double bond is untouched while addition takes place across the carbon-oxygen double bond, and it's a 1,2 addition product or direct addition product. We can also call it the kinetic product, in which this cyanide group attacks the carbonyl carbon, shifting this pi bond towards oxygen. This oxyanion which is formed then takes a proton from HCN, forming this cyanohydrin. So we can say that at low temperature, using sodium cyanide, against this alpha beta unsaturated ketone will lead to the formation of a cyanohydrin. With the same starting material and the same nucleophile, if you carry out the reaction at 80 degrees centigrade, you see here that the carbonyl is untouched, although we have this cyanide group attached at the beta position. Now you would think how this is different from this one. So you see here that addition has taken place at the carbonyl group and we have the formation of a cyanohydrin. Here addition or attack of this cyanide group happens at the beta position. Now this is supposed to be a 1,4 addition or the conjugate addition, but it should lead to the formation of a 1,4 addition product. But if you look at this product, it looks like a 1,2 addition product again, because you see that the cyanide group and the hydrogen from HCN, they are both attached at alpha and beta position. So it's a 1,2 addition product. But actually what happens is that this cyanide group attacks the beta position, shifting this triple bond here, which then shifts this pi bond here towards oxygen, forming an oxyanion. So by the attack of cyanide group, what we have as a result is this. This enolate anion is produced, which then takes a proton from HCN. So this oxygen is protonated, and what we get as a result is this eno. Now you see that it's a 1,4 addition product because the hydrogen has got attached to the oxygen while cyanide group has got attached at the beta position. So it's primarily a 1,4 addition product, or you can say that conjugate addition has taken place, or it's a thermodynamic product that is formed. But this molecule has a structural feature which we call the enol, and you know that enols can tautomerize to ketones quickly. So this enol then undergoes keto-enol tautomerism, and that converts this enol into a ketone. And because of this tautomerism, the hydrogen from oxygen changes its position, or it shifts from this oxygen to this alpha carbon, and so we have finally this product as a ketone having a cyanide group at beta position. So don't take it as 1,2 addition, it's primarily a 1,4 addition, but after tautomerism, it would seem like a 1,2 addition product. So this is how reaction conditions may influence the formation of a direct addition product or a conjugate addition product. So in conclusion, you can say that at low temperature, you will have direct addition, and at higher temperature, you will have conjugate addition. We'll discuss other factors later on in another session. Thank you so much for now. See you later.